All right. Today I'm gonna be talking about these beautiful trilobites, in particular about genera called Paradoxididae, Hydrocephalus, and the Paradoxididae. And I will also do some excursion into some other genera, as you will see. These trilobites are of Cambrian series 3 age, well, traditional Middle Cambrian, and they are generally considered to be monophyletic and closely related. So we can expect that if we have closely related trilobites, we should have very similar early stages. But that's not the case actually for Paradoxididae trilobites. The early stages of all these three taxa are quite different. These are very early protospid stages of Hydrocephalus. These two are of Paradoxididae, and this last one is of Paradoxididae. And you can see they are morphologically very different. You can see that these Hydrocephalus indeed have very hydrocephalic appearance. In Paradoxididae, this glabella is not as inflated as in Hydrocephalus, and in Paradoxididae, the glabella is very narrow, well furrowed. So they are in general quite different. So the question is why. If you look at them, we can clearly recognize two protospid stages of Paradoxididae. These three green dots are the first protospid stage. This is the second protospid stage. And of Hydrocephalus. And there is also probably second protospid stage of Paradoxididae and Paradoxididae. So not only they are different in the sense of morphology, they are also different in the sense of the size. You can see that that Hydrocephalus is the largest one. The Paradoxididae is something in the between, and Paradoxididae is actually and Paradoxididae, they are actually the smallest one. Here, this is I'm saying that because this is the second protospid stage of Paradoxididae, so it's actually smaller than the second protospid stage of Paradoxididae. So that's for the Paradoxididae trilobites. But if you compare these protospid larvae with other protospid larvae from the Cambrian, and also with some other arthropod larvae, you can see that they are really gigantic. This is Paradoxididae, and this is Hydrocephalus. And we actually think that this larger size could be caused by the fact that they were lecitotrophic. They had a lot of yolk in the eggs, so they grew comparatively larger than closely related species. And if you look at the paleogeographic distribution of the size of the trilobite larvae, you can see that along the equator there are quite small larvae. The trilobites have quite small larvae, but in the high latitudes, in the western Gondwanan margin, the trilobite larvae are comparatively large. So this is practically analogical with distribution of recent larvae of crustaceans, for example. They have also quite large lecitotrophic larvae in higher latitudes, and rather small larvae in tropical seas. There are also some different features on the larval stages of Paradoxididae trilobites. In general, ontogeny of trilobites looks something like that. It is characteristic by subsequent addition of individual segments. So the general pattern looks something like that. So you have the first stage, then you have second stage with 2 segments, then with 3, with 4, with 5. But in hydrocephalus, and also to some extent also in Ecaparadoxides, you have a first stage which has like just 1 postcephalic segment, and then you have the second one which has 7 segments. So and if you look at the recent crustaceans again, the general pattern, they usually have like 6 larval stages, but there are species that only have like 2 larval stages. They have kind of abbreviated development, and in this respect, this is a kind of abbreviation of the development, and this abbreviated development is also quite often present in a species which has lasitotrophic development. So this is another evidence for possible lasitotrophic development in these trilobites. The third evidence is something we called hydrocephalid morphology. You can see, as I already said, that these stages of hydrocephalus, they have very large circular glabella. And on the other hand, closely related species like Paradoxididae or some red-legged trilobites, they have very narrow, well-furrowed glabella that is not inflated. And we know that under the glabella there is an anterior portion of the digestive tract. And some recent crustaceans, they store, that are lasitotrophic or direct developers, they store some lipids from yolk under the carapax, and sometimes they also have very inflated carapax. So this can be also another evidence for possible lasitotrophy. So let's get through the post-protaspid development, which is like the part of the development from the larval stage to the adult. So we can see in Paradoxididae, the glabella is almost in all the stages very narrow, well-furrowed, while in Ecaparadoxididae, it is originally quite inflated, but then it starts to be narrow again, similarly as in Paradoxididae. And in Hydrocephalus, the glabella is very inflated, circular, almost during the whole ontogeny. And if we look at the taxa of Acadoparadoxididae or another species of Ecaparadoxididae, we can see that Acadoparadoxididae stages are rather comparable to Paradoxididae. And Ecaparadoxididae pradoanus is quite comparable to Ecaparadoxididae from I showed you before. So in conclusion, if we compare the development of these 3 Paradoxididae taxa, if we compare development of Paradoxididae and also of Acadoparadoxididae, then of Ecaparadoxididae and Hydrocephalus, we can see several trends that are coupled together. The first trend is increasing of the size of the larval stages. The second trend is increasing abbreviation of development. And the third trend is that in Paradoxididae there is practically no so-called hydrocephalid stage, no stage in the ontogeny of Paradoxididae does have this hydrocephalid morphology with inflated glabella. In Ecaparadoxididae, there are few stages at the beginning of the postembryonic development that have this inflation of glabella, but not at such extent as in Hydrocephalus. And in Hydrocephalus, this hydrocephalid morphology is occurring practically during whole life cycle. So we actually think that because not only the adults can be subject of of some selective pressures, but also some juvenile stages or larval stages. So we actually think that this is just a larval adaptation to some different environmental pressures, such as higher latitudes, unstable primary productivity. So they could develop something like non-feeding latitotrophic stages in species that were inhabiting different areas. Yeah, that's all. Thank you for attention.